Dear teacher, my name is Yu Xiao and my student ID is S1560726. This is my BIT362 Digital Forensic Assessment 4 presentation. The topic assessed to me is emails. In this presentation, I will explain how I conducted a digital forensic investigation of a test email sent from a Gmail account to a Melbourne Polytechnic Outlook student account. The purpose of this investigation was to identify the source of the email, check where the email shows signs of spoofing, capture related network traffic, verify the integration of the attachment, and examine local download effects on a Windows computer. To complete the investigation, I used 546 technique, email header and routing analysis, SPF, DKIM, and DMARC authentication analysis, Wireshark network capture, SHA-256 hash verification, and Windows file system artifact analysis. I will now briefly introduce the investigation scenario and then demonstrate each technique. This is the network topology used in this investigation. The test email was sent from Gmail to the Outlook mail. The email included an attachment called evidence.txt. The receiver opened the email in Outlook webmail and downloaded the attachment to a Windows computer. The main tools used in this investigation were Outlook Message Detail, Wireshark, and PowerShell. Outlook Message Detail was used to inspect the email headers and authentication results. Wireshark was used to capture network traffic. PowerShell was used to verify the attachment hash and inspect local file system artifacts. The email access and attachment download used encrypted web communication, mainly TCP and TLS over port 443. The first technique is email header and routing analysis. This technique was selected because email headers contain important forensic fields, such as form to return path, message edit data, and receive the fields. To complete this technique, I open the email in Outlook Web and use the message detail to view the raw email header. From this header, I collected the sender address, receive address, return path, message ID, timestamp information, and receive field. This field help identify the sender account, the receiver account, the unique message ID, and how the email was processed by mail servers. The limitation is that some visible sender fields can be forget. Therefore, header analysis should not be used alone. It should be combined with authentication results and other forensic evidence. The second technique is email authentication and spoofing detection. The authentication results was also collected from the Outlook message detail headers because the raw header is long and difficult to read clearly in the small window. I will show the recorded evidence in Figure 5. Figure 5 shows that SPF, DKIM, and DMARC all passed. SPF checked whether the sending mail server is authorized to send email to for the sender domain. DKIM verifies the email signature and links the message to the sender domain. DMARC combines SPF and DKIM results with the domain policy. This past result supports that the email was sent through an authorized Gmail mail server rather than a simple spooted source. The limitation is that SPF, DKM, and DMARC cannot provide the real human use behind the account if a legitimate Gmail account is compromised. The email may still pass these checks. The third technique is Wireshark network traffic analysis. This technique was selected because network traffic can provide independent evidence that email access occurred from the local device. To complete this technique, I opened Wireshark, select the VLAN interface, start package capture, access the email and the attachment in Outlook webmail, and then stop the capture. I applied the display file with DNS, TLS, and TCP. The capture showed communication between the local device and the external service over port 443. Port 443 indicated HTTPs or TLS encrypted communications. This supports that email-related network communication occurs during the email access and attachment download. The limitation is that Wireshark cannot directly show the email contents or attachment contents because TLS traffic is encrypted. The local IP address may change depending on the current network, but the capture method is the same. The fourth technique is attachment hash integrity verification. This technique was selected because file integrity is important in digital forces. To complete this technique, I saved the original file evidence TST and the downloaded file received evidence TST in the same investigation folder. Then I use PowerShell command to calculate the hash value of both files. The two SHA-256 hash values are the same. This means the downloaded attachment was indeed identical to the original file and was not changed during transmission and downloaded. This limitation is that hash comparison proves file's integrity, but it doesn't not prove who opened the file or who controlled the email account. And the fifth technique is the file system and download artifact analysis. This technique was selected because local file system artifacts can support evidence that a text was downloaded and stored on the receiver's computer. First, I used the PowerShell get item to check file name, file size, create time, last access time, and file path. This metadata shows that the attachment exists on the local Windows computer. Second, I use getContent with the stream parameter to inspect the Zoom.identifier alternator data streams. The result shows Zoom ID equals 3. Refer the URL at Outlook Cloud and the host URL at Outlook Cloud. This supports that the file comes from the Internet Zone and was associated with Outlook webmail. The limitation is that file metadata and Zone identifier data can be changed or may be lost if the file is copied in some ways. Okay, let's move back to the document. Overall, this investigation used 5 evidence sources: email header, analyze, identifier, the sender, receiver, message ID, timestamp, and the routing information. SPF, DKM, and DMERC authentication results reduce the likelihood of simply email spoofing. Wireshark confirmed encrypted network communication over port 443. SHA-256 hash comparison verified that the attachment content was unchanged. Windows file metadata and zone identifiers proves that the attachment was downloaded from Outlook webmail and stored locally. The main lesson learned is that email forces analysis should not rely on one screenshot or one tool. A stronger conclusion needs email header evidence, authentication results, network traffic, hash values, and local file artifacts together. In conclusion, The test email was sent from the Gmail account to the student Outlook account. Past authentication checks was assessed through encrypted network traffic and the attachment was not changed after the launch. Thank you for your watching.